All right, gang. Welcome. This is an introduction to Lab 1. First of all, prereq to this lab is going to be the Simulink video that I will have already posted. I haven't actually made it yet, but I will. So please watch that first, okay? And that's about how to program in Simulink, and specifically Simulink is a block diagram programming language. Okay, so like I said, watch that first. Okay, so in this first lab, what we're going to do is we're going to simulate, the whole goal is going to simulate a differential equation using block diagram programming. That's just one option, obviously. Oh, and I should say there's one is going to be ODE 45, so that's technically more, so MATLAB, think MATLAB, just general MATLAB programming, and then B is going to be Simulink, okay, and that's going to be the block diagram programming. All right, so ODE 45, you should have, even though I walk you through it in the lab, you should have some experience. Obviously, go help ODE 45 or Google ODE 45 to refresh your memory. That said, I want to talk about how to turn a differential equation into a form that you can then use blocks to create that. Okay, so first of all, we're given a differential equation. Okay, so specifically the one we're given in this lab is the differential equation of an RC circuit, which is, let me do it in green, RC V out dot plus V out equals V in, and all those functions are functions of t. V in, V out are functions of t. I'll even just add of t there, and you could do the same with V out, but I've already written those. And I'm going to call this equation 1 for later purposes, okay? So we're given this differential equation. So here's the big picture. Let's call it the big picture. The big picture is actually the drawing that I've already shown you, which is the following. You have a system, and you have an input, and you have an output. Okay, and of course we're given a system, the ODE, and so I will write that's defined by 1. The input is going to be V in of t, that's given. And then finally the output is V out, and we're trying to solve for that. Okay, so that's the big picture. Now, in block diagram programming, we're going to draw, basically, we're going to try to make it look like this, where, do it in red, okay? So I'm going to start the block diagram programming, and this line defines my V in of t, and it's defined by some block, like a sine function or a step function or whatever. It's a block. Input, it's my function block. Let's just call it, let's just leave it as some function block that you're going to find in the library in Simulink. And then I'm going to have an output, just like this. So that's going to be, in our case, V out of t. And it's going to go into either a scope block, so that we can view it. You'll also put it into a save to workspace block. Maybe you'll do both. So you'll tap here, and you'll have another block that's save to workspace. Again, I've already shown you these blocks in the Simulink video. To workspace. Okay. So now our job is to fill in the differential equation in block form. Okay. So here's the thing. There's actually two options. All right. Remember, let me actually grab this so we can look at it. Okay. All right. Now, there is option 1. Okay? And option 1 is going to be solve for the output in 1 and then draw differential equation. And I'll show you what I mean by that. Okay, so let's do that. All right, first of all, I'm going to, let me just paste the differential equation so I can see it. Of course, I can't paste. Paste. There it is. That'll be, this is, I'll get there. Maybe I should pause this and paste. Not going to happen. Okay, we'll leave it there. That's fine. So now, as I said, I'm going to solve for V out. So that's V out equals V in minus RC V out dot. All right? Same thing. I just took it and converted it by solving for the output. So let's draw this, okay? So V out is equal to the difference. So I'm going to make a difference block. Actually, I'll leave it in black. I'm going to make a difference block right here. So the output of that difference block, and I'm going to do plus minus. That difference block is going to take the difference of V in, so I'm going to draw a line into V in, so that's going to be my plus V in, okay? And then I'm going to take my V out, I'm going to tap off of V out, and I'm going to pass it through a derivative block, and then, which will give me my V out dot, and then into a multiply, which is our gain block. You can also use a product block. There's 2 different ways, but I like the gain block, which I already should have shown you. And then we're done. That's it. That's option 1. Draw the differential equation by solving for V out and then really using derivatives. All right. The other option is to solve for the highest derivative and then use integrals instead of derivatives. All right. So let me show you that. So what I'm going to do is I'm going to now, you can always pause, but I'm going to now erase this so that I'm ready for my option 2. Okay. All right. Option 2. Solve for highest derivative in 1, whatever the differential. You could have double dots, you can have triple dots, you'll just use more integrators, okay? And then draw differential equation. Okay, so let's look at that. All right, so first of all, I'm going to come back, I'm going to tap on here, and I'm going to draw this. So that's V out dot equals 1 over RC, just a little bit of algebra, and V in minus V out. Done. Okay? Now let me draw that. So I'm going to go up here, and I have a problem. There is no V out dot. There's only a V out. But if I use an integrator, which in Simulink is 1 over S, and we proved that in the Laplace transform lectures. So 1 over S is the same as an integral. So what goes into here is V out dot. Now I've got V out dot. And again, if you had higher derivatives, you just have more integrals, down here to try to get up to V out double dot or whatever. All right, now I'm ready to go. Now I take I have to multiply by 1 over RC, so I need a gain. So V out dot is equal to the multiplication of 1 over RC times the difference V in minus V out. So let's get the difference block. again, the difference of V in minus V out. And I'm done. Okay? So that's what you're going to be doing. In the future, I want to highlight that the higher the order the differential equation is, the more you will be using option 2 only. Option 1 in this case works because it's only a first order. When you get higher order, option 1 actually no longer works. But I still just want you to kind of play with Simulink. But note that option 2 is really the way you will use it in the future, and you will not use the derivative method. Okay, and I can tell you a little bit about why later. Okay, all right, have fun with lab 1.